Today let's take a look at section 8.4 on an introduction to functions, and we'll be talking about both relations and functions initially. Relation is nothing more than a set of ordered pairs. So you can see in my example I have 4 sets of ordered pairs. All of those would be relations. A function is a special type of relation. It is a relation in which each first component of the ordered pair is matched with one and only one second component. So the question I asked below the example, which of the above relations are also functions? So if we look at A, we see that we have no first element repeated. So each first component is matched only with one second component, so that means A. Let me get my pen working here. Let me see if I can move my... Okay. Let me put that back up to the side. Okay. So A would be a relation. That's function. Now let's check B. Alright, B gives us a problem because we see 1 is matched with 1 and also with 2. We also, with 2 and 3. 2 is matched with 4 and 5, and 3 is matched with 6 and 7. So each first component is matched with more than one second component. So B is not a relation. Or not a function. It is a relation, not a function. Okay. C, alright, as I look across, I say 0, 1, -1, 2, and -2. So each one is different, so we don't have to worry about that one. Okay. As we look at D, we see 1, is matched with 10 and -10. 2 is matched with 20 and -20. 3 is matched with 30 and -30. So because we're seeing duplicates, 2 and 3 occurs twice, that one is not a function. So A and C rather, are the functions. Okay, now a relation, I want to try to show those. A relation, the set of all first coordinates in a relation is what we call the domain of the relation, while the set of all second coordinates is the range of the relation. So we need to come up with the domain and range for each of the sets. We have A, B, C, D of ordered pairs. So the domain of relation number 1, which is also a function, would be 1, 2, 3, 4, 5. We just want to list all the x coordinates. The range will be all of the y coordinates, which would be also 1, 2, 3, 4, and 5. Okay, the domain in B, it's a relation but not a function. It would be 1, 2, 3. They're the only x's that are used. The range, we have 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Okay, in C we have another function. It's a relation and a function. We have 0, 1, -1, 2, and -2. Sure that shows up as negative. Alright, our range is 0, 1, and 4. Okay, D, which is a relation but not a function, our domain, we have 1, 2, 3, just 1, 2, 3. Our range, we have 10, 20, 30, -10, -20, and -30. Alright, the graph of a relation is a set of ordered pairs. For a relation to be a function, it must pass what we call the vertical line test. If you place a vertical line anywhere on the graph of a relation, it may only touch the graph in one point for the relation to be a function. Okay, so what's happening when we put a vertical line, if it touches it in two different places, what's happening is the same x has different y's. So let's start with, here are x and y axes, and let's put a straight line in there. Okay, so as we note, anywhere we put a straight line, a vertical line, as we can kind of do it with the highlighter, if I put vertical lines anywhere, it only touches this line I drew in one point. So yes, it passes, and yes, it's a function. All right. Oops, my drawing's not very good there. Okay. Well, I think what I'll do is just erase the whole thing and start over. Okay, so we have a parabola, and again, let's think about our vertical line. Anywhere it does pass the vertical line test, and therefore it is a function. Alright. Now how about this one? Uh-oh. It's hitting the graph in 2 points, so no. And no, it's not a function. What about a circle? Okay, again we can see it's hitting in 2 points. So no. Whoops. Leaned on the... Alright, so we've got one more graph here. Get my pen to write. Is that a function? Okay, our vertical lines, every one of them is only touching the graph in one place. So that one would be a function. Okay, a linear function is a function that can be written in the form f of x equals mx plus b. The graph of a linear function is a line. If f of x equals 2x plus 1, then f of 3 is 2 times 3 plus 1, which equals 7. So what you'll notice about this functional notation, f of x means the same thing as y. What we're saying is we know we have a function and we're giving it a functional name. So again, f of x, that is just another, or g of x, or h of x. All of those just simply are another name for y. So when we find f of 0, it's going to be the y coordinate that goes with the x of 0. So f of 0 would be 3 times 0 minus 5, which is negative 5. To graph that as an ordered pair on a graph, x is 0, y is the negative 5. Alright, so f of negative 8 would be 3 times negative 8 minus 5. Negative 24 minus 5 would be negative 29. So again, if I went to graph this, x is the negative 8, y is the negative 29. Okay, f of 6. So we'll have 30 minus 5, which is 25. All right, g of 1/2, I'd have 10 minus 4 times 1/2. 4 times 1/2 is 2. G of 5, so that's 10 minus 20, which is negative 10. G of negative 3 would be 10 plus 12, which would be 22. Okay, and that wraps up the lecture for 8.4.